Hello, viewers. Hello, everyone. Greetings from Jesse Precious. Today, with you, I'm here with my Jesse Polymath project, and I want to take out this beautiful opportunity to wish everyone happy holidays and a happy Easter in prospect. So, today I have come with little quizzes from our external examination board, and I am really eager to try this out with you. But before we dive right in, I would like you to take a little peek at our Facebook group, the Midas Touch Academy. Really, it's really incredible. The things we do here are amazing. We try to keep students updated on a few things, teach them from a distance, and even updates like this one now. So maybe you could take your time, Midas Touch Academy, and this happens to be our icon, set of students in class with their tech and gadgets, everything. Because that's the entire idea of Midas Touch Academy. We try to make sure that students are taught even from a distance effectively without being affected
Through these
whatsoever.
points,
So
and
this is one
then
of us in play.
guest here.
Okay, but then
So from
this
here
is not what we're about.
to here
Let us
is
dive
one
into
complete
some
cycle.
other things.
Yes.
Okay,
Now from here to here,
seems to be persistent. All right. Okay, so let's dive into other things. Um, what do we have up our sleeves for this evening? Right. Okay, these are questions of the day. Oh God, two questions of the day. That is really going to be tough. Is it? Okay, it said the clerk mistakenly switched the two digits of the price of a commodity when recording her sales. If she recorded 18 naira more than she was supposed to, and sum of the digits is 8, there should be a comma here. Find the price of the commodity. Find the price of the commodity. I think we'll be taking this one after the other. I wouldn't want to read out the second question until we're sure of what we have. Okay, so um, what is it about this? I feel like this first question here is about simultaneous equation. Why do I think it's a simultaneous equation? Let me give you my reasons why. So, why I said so was because in the first statement it said two digits of the price of a commodity. She switched two digits of the price of a commodity when recording her sales. If she recorded 18 naira more than her sales, than what she was supposed to, and the sum of the two digits, let's say the two digits are x and y, sorry, x and y. Adding both x and y gives you 8. And then they now say, find the price of the commodity. Now, in place value arrangement, from what the question was trying to entail, in place value arrangement, they say that if she recorded 18 naira more than she was supposed to, remember the two digits were switched. So if I were to arrange it in such a way where we have place values, we could say um, x, xy, xy is greater than yx according to place value. And that means she recorded 18 naira more. If that is the case, that means when you say xy minus yx, it should be giving you 18 naira extra. You know, they're trying to tell you the difference between the two swapped digits or switched digits. But then, before you can do this right, you must have to recognize certain aspects in mathematics, and that is what we are going to consider here now. Um, okay, simultaneous equation. You already know about simultaneous equation for what it is. Even a few of my project has included um, simultaneous equation for what it is at some point. And you see, by this other side of the board, we have a little bit overview on it. They said simultaneous equation substitution method, of which it has several methods to solving this. Several methods I can assure you. One of which is the substitution method. We also have the one we call the elimination method. But you must have to have a strong background on the topic before you can be able to use elimination method, because there are special cases where it is easily used and applied. So, but that, by the way, if you could take a peek at this, we have solved the simultaneous equation, of which we know that simultaneous equation involves the finding of two variables from two different equations. Like this one here, we have y equal to x minus 3. This is the first equation, and we have the two variables which are x and y, and then here is the second equation, and still having the same two variables. So if you were to use the substitution method, we already have that in equation 1 here, because I prefer to call this equation 1. In equation 1 here, we have that x is already equal to y is already equal to x minus 3. You can now substitute wherever you see y in equation 2, you substitute it as x minus 3, of which that is what happened here, as you can see. Okay, let me find some highlighter. Good. As you can see, that's what happened here. And then you still follow the rudiments of mathematics, where 4 has to break the brackets. This is the coefficient of y. And then this happens. And this happens, collection of like terms. And further simplifications. And x is equal to 9. You can now go back to your equation 1, where y happens to be equal to x minus 3. Wherever you now see x, you replace it with 9, because that's the final outcome, and then you now have 9 minus 3, which makes y equal to 6. I mean, we are going to be trying this out, but then one more theoretical background you must have is that of place values. You must understand place values, but let's read the side notes on the simultaneous equation. Say for every simultaneous equation, there has to be different variables. Let's say two variables in this case, like the example by the side, and they said different variables which are known and a corresponding number of equations involving the variable simultaneously. Okay, what this is trying to highlight here, if I were to say, is that if you have like two variables, that means you must have a corresponding equation, the corresponding number of equations. So we must have also two equations. So if we add three variables, we would also have three equations. So in this case, let's go into this. Now that we're using the recommended method, which is substitution method, let's go into what place value has for us. So they said this concept enlightens us of the multiples of 10 behind every digit in a number. Let's say I have a number 182, sorry, a number 182, 182. So each and every one of the digits here has a multiple of 10 for which it is greater than the one behind it. So I could explain that further. If you have 2 here, 2 happens to have no multiple of 10. So it's like its multiple here is 10 raised to the power of 0, right? Because 10 raised to the power of 0 is equal to 1, and 1 times 2 would give you 2 as a unit. And then here now, which is 8, 8 has a multiple of 10 to the power of 1, of which when you say 10 times 8, or you can say 8 times 10, it would give you 80, of which 80 plus 2 would give you 82 in this arrangement. Then we have 1 here, which has a multiple of 10 as to 10 raised to the power of 2, which becomes 100. When you say 1 times 100, it gives you 100. Then you add it with 80, and then add it with 2, which happens to be a unit. So all of this sums into 182, as the case may be. Why am I bringing this up is because you have to understand this concept before you're able to solve that particular problem which is faced, or which we are faced with at the board. So, but then let me take you to this. Let's go over to the board so that you could understand a full grasp of this. But before I take you to the board, let's go back to the question for what it is. Now, looking at these questions, I'm still using X and Y in play, of which this information all matters. But the only place we might get to nullify is the last line. We need to strike through or strike out the last line, because there is more to what we have than just a switch in alphabet. There has to be a recognition of place values before any other thing. So, but then let's go to the board. I will represent all those information. I should take a last peek on it, and there we go. Right, so bringing you to this, I would say they said x, y is greater than yx. Remember, the values were switched, or the digits were switched, and if you added x to y, it would give you 8, and then so far so on. Now, if this were to be brought to proper view or x-ray, you would see that, let me show you, like the place value I showed you where I used 182 as an example and told you how the multiples come in play. Remember, they said that if xy is greater than yx, that means the difference between the two digits is 18, as that was represented in the question. Okay, let me put back the last line because it's more like a rough sketch. But then let me throw light on this aspect. It's not just x and y all combined. There has to be a difference by virtue of place value. So if x and y were arranged in this form, you have to understand that x is by multiple of 10 greater than y. So let's say y here is multiplied by this, and then here x is multiplied by 10 to the power of 1. And when you add the two of them, it would give you 10x plus y. Alright? That becomes 4xy. And then for this one, you would have here, because y is by a multiple of 10 greater than x, that means you would have here, for x first, you say x times 10 to the power of 0. Then we have y times 10 to the power of 1, of which in this arrangement you would have 10y plus x. Just note that 10 to the power of 0 is equal to 1, right? So in this arrangement now we have y, x. And then if these two were properly initiated, we can now say that 10x plus y is greater than 10y plus x. But then this is all by the ways. Let's go back to this. Wherever I see xy now, I'm going to replace it in the proper form, recognizing the place values. That means I'm initiating my simultaneous equation properly now. I would say x, sorry, let me clean that. I need it to be good. So I would say x plus y is equal to 8. And then here we have 10x plus y, all in the bracket, minus 10y plus x, all in the bracket, is equal to 18. First equation, second equation. So now, at this point, we could now do our first substitution or whatever. So let me make x subject of the formula in equation 2. In equation 1, make x subject of the formula in equation 1. And that would entail that you subtract y from both sides, and then you have that x now is equal to 8 minus y. Let's call this equation 3, because that would help us find the value of x in time. So wherever I see x now, I'd replace it with 8 minus y. And then coming back to equation 2, I would say substitute equation 3 into equation 2. And that would mean 10, all in the bracket, 8 minus y, bracket close, plus y, all in the bracket, minus, all in the bracket, 10y, plus, all in the bracket, 8 minus y, bracket close, equal to 18. Alright, so here 10 gets to break the bracket. 10 times 8 would give you 80, and 10 times minus y would give you minus 10y, and then we have plus y. Alright, so we have here minus, okay, minus 10 minus 1 here times 10y will give you minus 10y, and then minus also breaks the bracket. We have here minus 8, and then minus also multiplies minus y, and then we have here plus y, all equal to 18. I had to break the bracket for what it is. Now if you need an explanation to everything that happened for this section, I'll tell you for free that here we have 10y plus, all in the bracket, 8 minus y, bracket close, a bigger bracket, and then a minus. So if you were to simplify the first inner bracket, we have here positive 1 breaking the bracket, and then you have here minus, all in the bracket, 10y plus 8 minus y. Because when a positive sign is outside of a bracket, it doesn't really change much inside of the bracket. So now when this minus affects everything inside, it would now become minus 10y minus 8 plus y. That is how we came to this. And then we can now collect like terms. And then collecting like terms would mean minus 10y plus y. Alright. Minus 10y plus y minus 10y plus y is equal to 18 minus 80 plus 8. So minus 10y plus y would give you minus 9y, okay? It would give you minus 9y. And then we also have another minus 9y equal to, summing up everything here, you would have minus 90y. Is that it? Okay. 18 minus 80 would give you 62 or thereabouts. 2. Here we have 7. So we have 62 minus 62 plus 8. So when we have 18 minus 80 would give you minus 62. Then you can now say plus 8. 62. 12. I don't have a calculator, please permit me. 12 would give you 4, and then we have a total of minus 54. So we have minus 9y minus 9y would give you minus 18y equal to minus 54. You have to divide through by minus 18. This will cancel out this. Positive, negative will cancel out negative. And then y is equal to 54 divided by 18. That'd be 5. I'm thinking 5. I'm thinking 3. The answer should be 3. Or maybe not. So it should be 3. So, because 18 times 3 would give you 54. 4, 3 plus 2, 5. So y is equal to 3. Then you can now say substitute. Substitute y into equation 3. Wherever we see y now, we replace it as 3. So recall that in equation 3, x is equal to 8 minus y. So we would have 8 minus 3, which is equal to 5. So we have x is equal to 5. So this is what satisfies the equation. When you say 5 plus 3, that's in the order of equation 1, it would give you 8. And then when you say 53 minus 35, it would give you 18. This becomes our answer. So this is an external exam question, so I'm hoping that you found it easy. Let's go back to the presentation. Right back to this. Maybe you should watch out for the next video where we'll solve for the second question. It's all going to be fun, I promise. Stay tuned, stay blessed. Bye-bye.